Hello world, my name is Victor Engelmann. Welcome back to the series on professional network design using Linux. Today I want to talk about Kerberos, and I'm a bit excited because Kerberos is a big topic, and I wanted to make this video for quite some time, but we needed all the foundations that we've built so far, and now finally we can deal with Kerberos. What is Kerberos? Well, it's a single sign-on service, which means that you can log into it and then you are able to use different services like SQL servers, file servers, without authenticating against them again. The way Kerberos achieves that is explained pretty well on the Wikipedia article here about Kerberos, the protocol. Down here under description. So what happens is in Kerberos you have these two servers, the authentication server and the ticket granting server. And they often run on the same physical hardware, but you could run these two programs on different servers if you want. The combination of these two is called the Key Distribution Center, KDC. And what happens in Kerberos is that first you log into the authentication server. Okay, you give it your username and your password, and it checks whether your username and password are correct. And if they are, it gives you a so-called ticket granting ticket. Okay, down here, ticket granting ticket. And your computer just stores that in some file. And later, when you try to access some service, SQL server, SSH server, whatever, what your computer then will do is it will talk to the ticket granting server and give it this ticket granting ticket. Okay, and then the ticket granting server will talk to the authentication server, check that that this ticket granting ticket is valid. And based on that, the ticket granting server will then give you a key. Here in this image, this is this blue key. Okay, and with this key, you then go to the SQL server, file server, whatever, and give it that key, and then that server will ask the key distribution center, hey, is this valid? The key distribution center will say, yes, it is. And then you get access to the server without having to input your username and password a second time. Okay, now that we know how Kerberos works, let us set up a server. As always, I've prepared a Raspberry Pi, but I'm reusing the one that runs also my LDAP server because I want to connect the LDAP server and the Kerberos server in the future, but that's not what I'm going to do today. Okay, now on this Raspberry Pi, I'm going to install the packages krb5- I'm gonna hit tab to get a list of things that I could install now. Here, admin server. KDC. Let's also take krb5-user. Okay, it's asking me what realm it's supposed to create, and I think it takes just the domain name from my network configuration. So engelmann.local is correct for my realm. which servers do I want to use? Well, I want to use ldap server.engelmann.local. And the admin server I will also run on ldap server.engelmann.local. Okay, it's creating the realm. Okay, now the software is installed on the server. Now we have to configure it. And the first thing I will run is krb5_new realm. And with that I can set the domain admin master key password. So here it's prompting me enter KDC database master key. Okay, now the master key is set and it's telling me about this file here, etc krb5kdc/kadam5.acl. So that's an important file that we also need to edit. Vim isn't installed. Let's use nano. Okay, so this kadam5.acl is an access control list, and it's already giving us a good hint here that we should have */admin space *, which means that all users who end with /admin are supposed to have access to everything. And I think that's a pretty good default rule for now. So let's save that. And then edit krb5.conf. Okay, this is the main configuration file. Here we have the setting default realm is engelmann.local. It has pretty good standard settings here. So we have a realm for engelmann.local, which has a setting for the key distribution center and the admin server, both on ldap server.engelmann.local. Then we have a lot of other domains. So we could, if we were students at the MIT, for example, then without any further configuration, we would be able to log into user accounts on the MIT servers. Okay. By the way, you can see here the MIT has the Kerberos server kerberos.mit.edu, and that's a pretty good thing to have. If you name your Kerberos server Kerberos. And then your domain, then you don't even need to set KDC, because that's just the default that it would try if you haven't set anything. There's a pretty good page here on help.ubuntu.com/community/Kerberos, and that's a really good page about Kerberos. And down here they also explain with _Kerberos. I think that's actually the domain that would be tried first, even before Kerberos.domain. And again, if that's the host name of your Kerberos server, then you don't even need to configure your KDC then, because that's going to be the default that your clients will try to use. Down here you have an entry underscore Kerberos with a redirection to kdc.example.com. But notice it has here this underscore UDP dot domain name. And that's something that you find here on gnu.org, where it has this list here, underscore Kerberos.udp or underscore TCP, where you can specify which protocols you allow. Okay. And underscore Kerberos-ADM is your admin server. So with that you can put a default for your admin server and don't have to configure your clients. And by the way, it also tells us here that 88 is the port, the default port at least, on which your authentication works. So if there's a firewall between your client and your Kerberos server, then you need to open port 88. And for the admin server, you need to open 749. Okay, that's a pretty good thing if you want to have strong security, that the administration works on a different port, right? This allows you to put your admins in a different VLAN than your regular users, and then open port 749 only for the admins, right? And then your regular users cannot even try to attack your admin server, right? They can only log in on the authentication server. And by the way, if you have ever been in a Microsoft Active Directory and you've pinged your domain controller, then yeah, the ping tool will show you the host name of the thing you're pinging. But when you do that with a domain controller in a Windows domain, it will only show you the domain name. That's a bit odd. But yeah, this line here is precisely why you get that result right here. Here this reverse lookup will then just give you the domain name instead of the host name of the domain controller. I always found that a bit odd, but yeah, whatever. Okay, now we have this KDC and admin server. We could just throw all these out, but yeah, down here we might want to set .engelmann.local to look up here. We have the default realm is engelmann.local in uppercase, right? And here we also have it in uppercase. But yeah, Kerberos is case sensitive. So if we wanted to authenticate against engelmann.local, we would always have to write it in uppercase. Yeah, down here we can just set an alias with lowercase names. So okay, good. Save, exit, and restart Kerberos. The admin server and KDC. Okay, now we have a running Kerberos server for the domain engelmann.local. Now we need to fill it with user accounts and connect services to it. So, well, to authenticate services against it, we first need to create some users. And I don't think we could connect to the admin server right now because, well, we have no users created yet. So all we can do is we can use kadmin.local. Okay, that's a special tool for local access, which requires admin rights. And yeah, since I have admin rights, it allows me to log in as root/admin, the domain administrator. Okay, and here in this kadmin.local, we now have a prompt that we can use to create things. So, for example, add principal, add prink, and now I could create a user Victor at engelmann.local. Now I can set a password. And now the Kerberos server has a principal for my user Victor at engelmann.local. So let's log out of this tool and let's try to authenticate against that user. Okay. I'm doing this on the Raspberry right now, so I don't think this would work from my laptop yet. But yeah, on the Raspberry, I will now run kinit Victor at engelmann.local. Okay, with kinit, I can tell it I want to log into that or authenticate as this principal. I input my password. Okay, it looks like it has accepted my password. So we can verify that with klist, which tells us, yes, I have logged in as Victor at engelmann.local. That's my ticket granting ticket here in temp krb5cc_1000. And my ticket granting ticket will be valid until tomorrow. So yeah, I'm now logged in as this user. Okay, and at this point, if I had any services that were connected to the Kerberos server, I could now connect to these services without being asked for username and password. Okay, now if for testing purposes or whatever reason you want to log out of this account that you've logged into now, you can just call kdestroy. If I run klist now, yeah, there's no more ticket granting ticket found. So yeah, let me log in again. Good. Okay, now right now I have the server running and it has a user, and I can log into that user when I'm on that server. Okay, but of course I want to log into that on other machines too. So for example, on my laptop, I want to be able to authenticate against that. So yeah, first I will open another shell window here and install a package krb5. Yeah, the package could be named differently, like krb5-user or something, depending on the distribution. Okay, now I have krb5 installed. So here I now also have kinit, but yeah, on my machine I haven't configured the connection to the server yet, so it would just not work. Yeah, see, it would now try to authenticate against the MIT servers. Yeah, that doesn't work. So after I've installed Kerberos here, I need to configure it also to use my Raspberry as an authentication server. And this is also done in etc krb5.conf. Look here, default realm athena.mit.edu. I'll do this manually here. The admin server is ldapserver.engelmann.local, and the KDC. For reference, we can look on the Raspberry again. Yes, the field was called KDC. So KDC equals ldapserver.engelmann.local. Okay, now let's try logging into victor@engelmann.local. Looks like it worked. Yes, I have a ticket granting ticket for the principal victor@engelmann.local. Now, for security reasons, you should join your machine to the domain that you are running on your Kerberos server. And yeah, you can do that in the following way. You go to kadmin.local again. And yeah, here we can create now a principal for the machine. So we would again use add pring. But yeah, we wouldn't want to have it some insecure password. So I will use a random key, and yeah, principals for different machines start with host / and then the host name. So in this case, laptop.engelmann.local @ and then your domain. Okay. Okay, now this user has a password, but we don't know what that password is. Okay, so we cannot manually configure the computer to use that password, because to do that we would need to know the password, which we don't. But what you can do in Kerberos is you can use a command called ktadd, which puts a password into a so-called key table. Okay, and with a parameter -k, you can set a file like etc krb5 kdc / and yeah, I think I would call it laptop.keytab maybe. And okay, we also have to add the principal, so host / laptop.engelmann.local @engelmann.local. Okay, so now this password is in this key tab, and we could now transfer that file to the laptop. Okay, right now this is on the server. Now we could transfer that file to the laptop in whatever way. I don't know, maybe with a USB stick or with SCP, although that's a bit of a problem with the access rights, because normal users don't have read access to etc, and or at least not etc krb5 kdc. So with a normal user you cannot read that, and as a root user you're not allowed to log in via SSH. So that's a bit of a problem, but this is just a plain text file. You can just open it, copy the text in there, and put that into a file on your local machine. That works. But the way I will do it now is I will create a user at principal called root/admin. Okay, give it a password. Okay, principal created. And then here locally on my laptop, I can now run kadmin. Okay, if I run that, it would try to log in as wyOOS at engelmann.local. But if I run this with sudo, because I want to write to a system file from here, so I need to run sudo, and then because I'm running this with sudo, it then tries to log in as root/admin, which I just created. So I can use the password that I have just given it. And you see now I have logged in from my laptop as admin. Okay. This might not be something you want to allow. Maybe you don't want to put the program kadmin on your client machines in the first place, but yeah, now that I'm logged in as an admin from my laptop, I can now access this password from my laptop and write it to a local file with the same tool, kt-add-k. And here I would put it into etc krb5.keytab, because this file is the default key tab which Kerberos will use by default. Okay, so your later configurations don't need to say, hey, use this key tab. It will just use this one by default. And I will put there the principal host /laptop.engelmann.local at engelmann.local. Okay. Okay, and with this entry in this key tab, my laptop is now joined to the domain. It has kind of a client certificate with which it can authenticate against the Kerberos server, and this just gives you even more security. Okay. Okay, so now we have a running Kerberos server, and we can get ticket granting tickets from it. But yeah, I want to automate that. So whenever I log into my machine, I want to have such a ticket granting ticket immediately. Okay, I don't want to run kinit manually after logging in. And yeah, more than that, I want to outsource my whole authentication process to the Kerberos server. Okay, for the simple reason that then I can take all my machines, connect them to the Kerberos server, and when I change my password, it will the new password will then work on all my machines. Right? I don't have to go to each machine individually and change my password everywhere. And yeah, it has some more advantages, but that's really the thing that I want. And yeah, when we are using Linux, we are in luck, because as you know, Linux is very, very modular, and it's so modular, even the login process is modular and can be changed around with so-called PAM, PAM, for Pluggable Authentication Modules. Your distribution may have a tool for this. Red Hat, for example, has a tool called authconfig, I think. And you can use Samba for it in some way, but you know me. I'm a minimalist, I'm a purist. I want to do things in a simple way, and I want to know what's going on the lower levels. So I'm going to do this really deep down manually. Yeah, for that I will use PAM, Pluggable Authentication Module. And to use Kerberos from this PAM, we will need a PAM module called PAM-KRB5. Let me install that. Okay, so now that this PAM module is installed, we need to configure it, but that's a bit of a problem because, well, PAM is relatively complicated because the configuration of PAM isn't a configuration in that sense. It's more like a script, but in a weird programming language that's a bit hard to understand. This video here by Michael Lucas, PAM is Un-American. That's a weird title, but that's a really good talk about PAM. He goes into all these details and he really explains it well, but it's still a bit a somewhat unusual programming language, I would say. It takes a while to wrap your head around it, even if you have experience with programming. So let me log in as root. Here in etc pam.d, you have a lot of different files, okay? And yeah, for example, for the login command that is run at system startup, or when you have KDM or GDM, there would be a corresponding file here. I think SDDM is the one that I have here on Manjaro. There's one for su, for sudo, for SSH. So these are all scripts. And so let's look at, for example, into the script for login. Okay, this is how these PAM files look. You have these, the first column is one of 4 identifiers: auth, account, session, or password. And yeah, we are right now only interested in the auth section. And here it sets different shared objects, .so files, what you would call a dynamic link library, a DLL in Windows. Okay, and it says here to use this library, and after that this library. Okay, and yeah, this middle column tells it what to do if the library says you are allowed to log in or not. Okay, so there's again this video here, PAM is Un-American, which really goes into these details and explains all of that in detail. But yeah, what I want to point out here is the normal login, okay, has an authentication that includes system local login. Okay, what is that? System local login is the next file, so let's look into that. And this in all 4 sections just includes system login. The authentication includes system auth. Okay, that's the one I want to look into, system auth. Now this is the real script that is just basically used by everything else, the main script. And be careful. If you make mistakes here, you can break your login procedure and then you cannot log in anymore. I've locked myself out of my machine a few times. To prevent that, it's always a good idea to just keep one tab, one login open here where you are logged in as root. So even if you break your login, you are already logged in on that window, and then you can use that to fix your mistakes. Okay. So what we have here now are these lines: auth, the different shared libraries that are used for the authentication, and what to do with the different return codes that are coming from these shared libraries. Now, this is not standard across different distributions. Most distributions really do their own thing with PAM. So you really have to read this and understand it so that you can then decide how to manipulate that. Okay. Now, what Manjaro does, and I think Ubuntu does it similarly, is it has this line here, which uses PAM faillog.so with default equals die. This is the bad state. So if this line is ever reached, you've lost. Okay, then the authentication is over. You are not logged in, and this library will then increase a counter, remembering you failed to log in. And if that happens too often, then the line up here will already say, no, this account is locked. You are not allowed to log in anymore. Okay, so yeah, if you reach this line too often, then the account is gonna be locked, and then this line up here, if you try again to log in, will already kick you out. And yeah, what Manjaro does is that before you reach this bad line, you have several ways that you can log in. Okay, and yeah, PAM Unix is the standard one, which just uses the standard files /password and /shadow, and PAM systemd home mounts devices and such. Okay, but importantly, if a authentication method up here before this bad line succeeds, it then says success equals 1 or 2, which means we then skip 1 or 2 lines. Okay, and then we are down here, and this is the good branch of the authentication procedure, where we can then run a few things like, well, PAM faillog again with auth succeeded, contrasting to auth fail, which resets the counter. Okay, so if you have successfully logged in, then these 3 things are executed, and one of them is the resetting this counter of failed logins. And yeah, this one here sets up your environment, and you can do other things here. For example, one thing I did was I would put in here an auth optional PAM krb5.so with use first pass, which would just reuse the password that you've entered up here. So if your user account had the same password on the Kerberos server as you have locally, then it would just take your local password, try it against the server, and if it succeeds, you get a ticket granting ticket. That's a an easy way to get a ticket granting ticket on startup. But yeah, the problem with that is if you do that, then it only works if the two passwords match. And I think that's not really good, because yeah, you will change your password maybe, and then this whole mechanism won't work anymore. So I think the better way to do this is to go up here, auth. This minus, by the way, is only for suppressing some log entries, so don't worry about that. So if we succeed logging in with Kerberos, then we skip behind this bad line, right? And I increase this here to 3 so that I don't break this line. Right, so if we successfully log in, we go to the good path, and otherwise we go to the next line with this default equals ignore. Maybe I should put use first pass here and also here, because otherwise the module will prompt you for other passwords if the password isn't correct. Okay, and we just don't want that. If the password is incorrect, you just restart the whole authentication process. Okay, now let us try out if we can now really log in as our users from here. Let me add a principal matching my user that I have here on my laptop, right? WYOOS. Okay, I think I should be able to authenticate against that. Now, how can we try that we actually can authenticate against it? Well, I could log out of the of my desktop session and re-log in, but then this window here with the root login would be gone, which is not something that I want to risk. So what I will do instead is I will press Control Alt and then F3 to switch between the different login sessions that I get from my distribution at startup, so that my desktop session keeps running in Virtual Terminal 2, but then I go to a text terminal 3. Okay, I don't know if you know that functionality, but with Control Alt F1, F2, F3, you can switch between different virtual terminals that you get on startup. But I'm guessing that this will kill my my screen recording, so I will just point the camera at the screen again. Okay, now I press Control Alt F3. Put this little sticker here to help the camera's autofocus. And yeah, up here I can now log in WYOOS without the @engelmann.local. Okay, and I will now use the password that I have on the Kerberos server. And you see I have successfully logged in. Okay, log out, Control Alt F2. So I'm back to the desktop environment. Now after I've successfully logged in on the other session, I will now dare to log out. Did I mistype? I know what the problem is. Here outside of this session, I don't have my Wi-Fi connection. That's something that's running inside the session. So yeah, now I cannot reach the authentication server. Okay. Okay, now I've plugged the laptop into the same VLAN that also has the Kerberos server. And there, it's logging in. Okay, so there you have it. We have a running Kerberos server with some principles. We've joined this laptop to the domain that it's running, and we've used it to log into the laptop. And just to make sure, again, I've just logged in klist, and I have a Kerberos ticket granting ticket here. So this whole thing worked with just logging in. We are now getting this ticket granting ticket. So at this point, just by logging into the computer, we would now be able to log into all services that are connected to the Kerberos server, which right now are exactly 0. So yeah, that's what we will do in a few future videos. We will connect several services to the Kerberos server. But yeah, one more thing I want to point out. If I weren't to if I created yeah, a principal now, I don't know, let's say ishtar at engelmann.local. I would now not be able to log into that account. Okay, and that's a problem because yeah, my laptop doesn't know this account exists, and it's looking locally for existing accounts. Okay, and yeah, that's a bit of a problem in Kerberos, which we will address in a future video, where we will connect the Kerberos server to the LDAP server and pull the existing users from that. So then we can use the LDAP server to figure out which users exist, basically. Okay, so yeah, but I think for small setups, let's say maybe, I don't know, 20 machines or something for a small company, I think this is actually already enough. It has a little drawback that you need to create all the user accounts on all machines where you want to log in, but then yeah, then you can log these users in on these machines and get ticket granting tickets. Okay, so that's all I wanted to show you today. If you like this video, like it, share it, subscribe, and see you next time.